Alright, so another help request for exercise 11.1, again specifically for part 2, and so far I believe there's two Professor Paluch debugs codes online for exercise 11.1. The first one was with regards to part 2, and so this one will also be with regards to part 2. So help 1 and 3 will both be with regards to part 2. And so here it was basically just adding that for loop to loop over a range of masses, and for each mass determine the optimal launch angle. Right. So hopefully in 1 you're able to write code so that for a given mass you return the optimal launch angle. Now in 2 you're just going to loop over masses. You're going to look at a range of masses. Okay. And so let's take a look at the code here. Okay, and let's see what we have. So right off the bat, the code is a little different than how I might set it up, which is fine. And what we've done in class, in that it's a script that has helper functions. Right, it's a script because the file begins with commands and not a function signature. Okay, and so we really haven't done this in class, only because it was only fairly recently, I want to say maybe MATLAB 2015, that started to allow you to have scripts with local functions. Okay, but it's going to be similar in that when I call my script from my command window, right, you start at the top. You would only call any of those helper functions if they're called upon. Okay, but it'd be similar to calling the top. The script can of course have access to your workspace. So let's see what we have. Okay, so we call cannon mass angle, where you create your vector of masses over the specified range. Initialize a vector of optimal angles for all those corresponding masses. That's great. Loop over your vector of masses, and then for each mass, right, presumably you would solve this. Okay, good. So first thing I notice is that you pass the mass to my helper function here. Okay, so this ought to be, and this again looks similar to help 1. It's similar to the comment from help 2 yesterday. But when I look at mass here, right, this is the mass that I'd be receiving as an input. It's underlined because it's not currently used at all. Okay, so we'll take a look at that. So my initial position, my initial velocity, the range of angles you'll look at, cool. Calculating your initial velocity in the x and y direction, your initial time, velocity of distances traveled upon impact, looping over all my angles, right? So you create this vector of angles. So for a given mass, you're going to loop over all those angles and find the maximum distance traveled. So within here, T impact is underlined, but that's only because, well, it's not really used. We just use F0 to solve for the time it takes to hit the ground, and use that as our final trajectory, but we don't actually use it. Okay, so that looks similar to what we've had before. Then projectile solve is, okay, now I need to keep track of level of indentation. So this is nested within my top function. As is my rate function. As is acceleration. Alright. So we said mass wasn't being used at all. So if I look at my error function here, mass isn't being passed there at all. But okay, so these are nested so they can see m vector is defined in my top function. Okay, so if I look for where n vector is, assuming everything else is correct, m vector appears here. So that should be this. So why isn't that the same? Unless this is just a subtlety of scripts, I don't know. But it shouldn't be. So the issue I'm having is this mvect up here is still underlined, which suggests it's not being used. And that's not Cheyenne, so it's not suggesting that it's seeing that. So let's try and run this, and let's see what error message we get. Because everything else looks the same as compared to what we've had. Okay, so I don't see any issues other than this issue with that mass vector, or mass vect not being used. So this is 11.2. So it's just a script, so I should just have to click to run it. And let's see what error message we get. Oh, I'm sorry, ran the wrong one. That's question 2, which was also asked about. Yeah, so 11.1.2. Okay, so error message here. Not enough input arguments. Okay, so let's move this over here for now. Projectile solve. I mean, that's proper F0 call. Projectile model angle. So projectile model angle has one input. So this has multiple optional outputs. That should be fine. If you call it like that, you're only going to get, you should only get theta naught back. And so what is, oh, so I'm not sure if it's exactly it, but one issue here is you're returning theta naught and x impact. Okay, so theta naught right here is your vector of angles that goes from 30 to 60 in increments of 1. Right? So it's actually your vector, and that's not what you want. X impact would be your vector of distances traveled, right? So you don't want that technically either, right? X impact is also going to be a vector. So what is this animal returning? So so it doesn't look to me like you actually solve for the optimal launch angle, right? Because if I follow through this, you're going to loop over angles, right, for given mass. You compute the distance traveled, but that's it, right? So let's say, let's just use the max function for now. So let's find an angle that gives maximum distance. Right, and so let's not return those vectors. Let's just call this, we'll just use res, and res will be my optimal launch angle. Okay. I still don't know what's up with that mvect being underlined, but let's take care of one thing at a time. So, first find index of max distance, and so what I'll do here is we'll call him max I, max index will be 1x impact equals max of x impact. Okay, so we're comparing our entire x impact vector to, so that's a vector, so max x impact will be and should be a scalar as long as there aren't multiple occurrences of that maximum value. That'll return the maximum distance traveled. So the result of this will be a logical vector of ones and zeros, one corresponding to when that maximum distance occurs. And so then we could use that to filter our theta naught vector. So this is theta naught is our vector of all angles. We want the one where that max distance traveled occurs. Okay, so now this will at least be set up so this will return the maximum distance traveled, which is what you want to store to this theta opt I. Okay. So that actually gives you theta opt I. Yeah. Oh, so you have mvect here. So then res here, you want this to actually return. Oh, no, I take it back. You have res set up so that it splits out mvect and theta opt. Okay, these are going to be vectors though. And now we just need to figure out what type of vectors they are. So mvect is going to be a row vector, and so theta opt will be a row vector. So here, this probably isn't what you want to do. So if mvect is that a vector of length 100, use linspace. So mvect will be a row vector of length 100. That comma would be a horizontal catenation. You're going to stick another 100 columns onto it. So the result's going to be a vector of length 200. Let's do this so that we get row 1 will be essentially columns 1 through 100 will have your masses. Then you go to the next row, so row 2, columns 1 through 100 will be your vector of thetas. And so then if I do that, mvect would be row 1, all columns. Theta opt would be row 2, all columns. Okay, so we've done a couple of things here, but does that magically fix it? No, it doesn't fix it. Still have not enough input arguments. All right, let's take this piece by piece. Okay. And, hopefully it's not something just having to do with having these helper functions that I just completely am unaware of, but let's hope it's not that case. Okay. So I'll interpret this as this is calling canon mass. Canon mass has no inputs. You create your vector of masses, vector of theta ops. You loop over your masses. And then for each mass, you want to solve for the optimal launch angle by calling projectile model angle, which is that helper in parallel. And you're going to pass the ith element of mvect. Okay. That seems fine to me. Okay. So you call projectile model angle with an input of mvect. Okay, let's hover over it, see if the message tells us anything else, but this would just be that it's unused. So why is that? So let's see. So my initial position, my initial velocity, my initial angles I'm going to consider. Go ahead and pre-compute the initial velocities, initial time. Okay, and those are all Cheyenne, right? These Cheyenne ones mean they're shared via nested functions. Vector of to track the distance traveled. But I'm not sure how important it is since we're not returning it. Okay, so that's because the vector is going to be created in a helper. So you loop over your angles. For each angle, we're going to solve for the time it takes to hit the ground. And I don't see... Oh no, we need that because that's how we're going to solve the max distance. So you call this guy, and that should be fine. Those are all Cheyenne, so they're all shared from above, so you have them. Oh, okay, here we go. So that's projectile acceleration here. So acceleration here has inputs of TP and V. Here you have inputs of TP, V, and mvect. You don't want mvect here, all right? So you're not passing it. You've already nested this animal, so it can see mvect in that parent function that it's nested in. So now I delete that. Now mvect becomes Cheyenne because it can actually see it up here, right? Rather than passing it, thinking that I have some local variable. Okay, so all I did is delete mvect. Then you magically saw these turn to Cheyenne because now it has access to the workspace of the vector or function it's nested in. Now up here, this is Cheyenne. It's no longer yellow. Okay, so if we run that, drum roll. Plus, we found a couple other issues related to vectors earlier. Haven't got any error messages, just running. So we'll let it run. This might take a little longer. So I would encourage you to have a look at the first help video where we talked about some of these optimization techniques to get the code to run faster. Mainly setting a minimum theta in your search of angles for each mass. And then that can propagate. So if you go from low masses to high, as mass increases, we expect the optimal launch angle to increase until it gets to a value closer to 45 as that drag becomes less important. So you can use that as a trick to speed it up. The other trick we used to speed it up is we had an exit or early exit from our for loop, where rather than compute distance traveled for each angle, we continuously check to see if our distance traveled started to decrease as our angle increased, at which point we'd have gone through our max, and then use that to break out of the for loop and pull your max out. Yeah, so now it looks like it works. It's a little choppy here. That's just going to be an issue of your precision. So I'd say have a look at help 1 and some of the optimization techniques we looked at to get the code to run faster, but then also to get a more precise result. All right, so that was a tricky one, but I think I got it. I think we got it working. So let's just make this full screen here. So a big thing was, well, one, we fixed up mvect and theta opt based on what you're returning. And there I think you're just kind of confusing having multiple optional output variables. And then what you're actually doing here is you're packing up your solutions into a matrix. So when I look at mvect, I know a len space creates a row vector, and theta opt you're creating a row vector, right? One row, that many columns. So when you get a column here, you're actually stitching those two vectors together to make one super long vector. What we want is, instead of matrix, where mass is row 1, theta is row 2. So when we get that returned, then we have a way to chop it up. Okay, so that was one issue. The other issue, right, was, well, you actually need to return the optimal launch angle. And so we just did a simple, use the max function just to search within our vector of distances traveled to find the largest one, return the corresponding index, and then use that to pull out the angle. And so this would work, again, assuming that there's going to be no occurrence of that same maximum distance, right? There should only be one. So we added that piece. And then the biggest part was just removing mvect as an input here, so that it used that value from the function in which it was nested. Okay, cool. So that fixed it up. I would encourage you to have a look at help 1, where we talk about how you might make your code more efficient so you can get rid of some of those choppiness. And, you know, is your code wrong because you have that choppy plot? No, not at all. But I, would encourage you to take a look at help 1, where we talk about how to make your code look faster and how you might be able to get more data points to decrease that choppiness. But all right, there you go.